So it's probably like pre-algebra with a little bit of algebra in it. Looks like you guys are doing slope right now, and
Yeah.
maybe that is the first time you've seen it. So this is definitely enough for us to get started. So let me go ahead and jump off camera here. I'm going to nip in some questions and we'll get started here.
Okay.
All right. So let's see here. All right, let me grab some news. I just sometimes it takes just a bit to get started, and I'm gonna snip something in, and then we'll work on it here. So looking at this kind of the graph's not great, but you can see in your book there. We got kind of a graph here, a line going up straight up to the right here. You probably saw this in class. Slope is rise over run like that. Does that look familiar
Yeah.
to you? Okay,
Yeah.
and rise actually could mean going up or it could mean going down, but run is always to the right. You're always going to the right. Like we read left to right, we do math left to right. It's always left to right, left to right, left to right. Okay. Now, what you
Hmm.
typically do here is you find a point that's on the graph, like right there, boom, and let's just pick another point on the graph there, like that. And since we're going from left to right, we know we're going from this point on the left to this point on the right. You either go up or down. So in this case, we're going to go up. How much up are we going? In this case, it's 20. To the right, it's 1. Do you see that?
Oh, yeah.
Okay, now
Uh,
this is scale is different. Like I don't know why they're choosing this, but in this problem, you got to pay very much close attention to the scale. The slope is 20 divided by 1. All right, does that make sense to you?
uh-huh.
All right. So I'm actually going to grab some other questions for us to work on today that are a little bit better for students that are working this out for the first time. So let me go
Okay.
ahead and grab. Sorry.
I said okay. Sorry.
Yeah, sometimes there's a little bit of getting used to going back and forth. But apologize if ever interrupt you here. So here's the graph. Again, there's typically 2 points. We'll call it A and B. Okay. And hopefully this is large enough that on your screen you can see what I'm referring to here. So to go from A to B, how many up are you going to go? How many units up do you go to go from A to then B? How many can you see there?
One.
One up. And how many to the right?
Um, three. Wait, no, two.
Two.
Wait.
You're just counting, right? You don't count the first one, 1, 2. So we've got a slope here of 1/2.
Mhm.
Does that make sense?
Yeah.
Okay. Let me have you try this one on your own. So you'll often see that I'll do a problem and then I'll ask you to do a problem here. Going from A to B, I want you to give me the slope. Basically, how much up and how much to the right are you going?
Okay. Do you count the black line, like the one in the middle?
Good question. So like, let's say you're starting at A, you just literally count, okay, that next intersection is 1, then 2, then 3, and then 4, and so on. So you count every like gridded intersection until you get to.
Okay. So then the rise would be four, and then the other one, I forget what it's called, would be
It's
one.
called it's called run, but I think it's more efficient to say to the right or more clear. Let's say, okay, it's going to the right, to the right, to the right. So that's literally what we're doing. We're going to the right. All
Okay.
right. Very good. So the slope here is 4. Let's have you try another one here. All right. So new problem for you again. You're going from left to right, from A to B. I just want the final answer. What is the slope to go from A to B?
Okay. Um, wait, so with the fraction, do you divide the fraction or do you?
It's okay to have a top number and a bottom number.
Okay,
So no, you do not divide, but you do have a top and a bottom number.
so it's 3/2.
There's 3/2. Good. Any questions on that before we go on to something else?
Nope.
All right. So slopes can either be positive or negative. All the examples that I did here are positive slope here. So this is negative slope. The reason it's negative slope is we know that it's going down and to the right. And like again, it's rise over run. So this time you're going down. You're going
Mm,
down one. When you go down, that's negative. So down
okay.
is negative, up is positive. And then the run here is 1, 2, 3, 3 to the right. It's always to the right, -1/3. Right. So you have to be aware, okay, if it's going down and to the right, that's negative slope. If it's going up and to the right, it's positive slope.
Okay.
All right. Let me give you an example to try here. Problem to try on your own. All right, here we go. All right, so I want you to calculate the slope here for me, please.
Four over two. No, -4/2. Right?
Like this, like this.
Yeah.
Okay, does this, so did you count 1, 2, 3? Looks like you counted an extra one. You don't
Oh,
count the first point. So let's try that
oh,
one more time.
okay. -3/2.
Very good. Very good. That is correct. Okay. Let me see here. Which one are we pulling from? Okay, I was pulling from that one. Let me give you another couple to try here. All right, here's another one for you to look at. All right, go ahead and calculate the slope of this, please.
Would this one be a -2?
If it's going down and to the right, it is always negative. Down and to the right.
Okay.
So yes, this has a negative slope. Do you have an answer for me?
Um, um, sorry, I got really confused, but I got it now.
Okay.
Negative, wait, rise. Wait, -2/1. And eight
Okay, so how did you get 1?
by the, oh, wait, no, over 2.
Okay. Give me some feedback because you're just counting. You're just counting. And if you're going down, it's a negative number. This bottom number is always positive. So give me some feedback. What seems difficult about this, or what is challenging to this about you? What do you see that's challenging?
Well, I just got confused. Was I had to think about the rise, like which one was the rise and which one was up.
Okay,
But
got it. Okay. So next question for you is, does the fraction reduce?
sorry, what you cut off.
Does this fraction reduce? Does this
Um,
fraction change into something different?
yeah.
Okay,
Wait,
I agree. Both of these numbers are divisible by 2, or you can take 2 and divide it by 2. What does it become when you reduce it?
wouldn't it be mm, bleh, um -1?
Yes, very good. Very, very good. Okay. All right, we're gonna do some more problems here. We're gonna change it up just a tiny bit here, right? And
Yeah.
the next type of problems that you will see don't necessarily have these points already labeled, okay? which means that you have to go in and label the points. Now, what you're looking for is like something that is right on the grid line right there. You kind of agree that that blue hits the grid perfectly there?
Yeah.
And then you go look for another one. It's got to hit perfect. So no, that doesn't work. Nope, that one does work.
Uh,
Okay. Now, is this positive or negative slope?
positive.
Yes. Right. So, so give me the slope here. Go ahead and you're just counting. Give me the rise over the run. Take your time.
Eight over three.
Okay. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Does this reduce?
Uh, no.
It does not. Good. Okay. Here's another one for us to look at. It's again, you kind of have to, and it is hard without having it in front of you. So I'm gonna help here. You look for those perfect kind of grid points right there, and then you look for another one. Like that's one there. But if you're not sure, like I'm not really sure, you go and say, well, maybe that one's a little bit more perfect. But you want to find two gridded points there that hit the grid. So does this have positive or negative slope?
Negative.
Negative. Good. Okay, go ahead and calculate the slope for me, please.
Negative 4/6.
Okay. Does that reduce?
Yeah.
Okay, what does that reduce to?
Uh, 2.
You can divide both the top and the bottom by 2. What does that become?
2/3.
What happened to the negative?
Oh, -2. Sorry.
Good, really good. Yeah, it comes with it. You know, you can't just drop it off, even though maybe you want to. All right. Now, that's from the graph. Okay, it looks like you're also given some problems in your assignment where they give you a table. Um, it looks like
Oh, yeah.
they've given you some problems. Okay, they're like, here's a table, or I don't know. I guess most of them are graph. Um, we're kind of beyond that, but that's okay.
Yeah.
Did you guys get an equation for slope in
Um,
class?
no.
Does this look at all familiar to you?
No.
Okay, good. We won't do that then. All right. Trying to decide what to do next with you here because I guess we can do some more slope. Okay, let me grab a couple more problems here for you to try. All right, so this one I'm going to ask you, I'm going to make it as big as I can to fit on the screen, but I'm going to ask you to determine the slope. Wait a second. No, we have not done this. Sorry, I thought we'd already done this one. I'm going to ask you to determine the slope. I won't move the screen around. You're going to have to pick the points though to use.
Okay. Wait, sorry, what'd you say?
I want you to determine the slope, but I'm not gonna give you the points. You have to figure out which points you want to use to count on this graph.
7/6.
Okay, which did you use this point here?
Yeah.
Okay, and then did you use this point here?
Uh, yeah.
Okay, try that one more time. Just count one more time. I know it's a little bit tough going through the screen, but give that another shot, please.
Six over 4?
So we're just counting, right? One, two, three, four, five. We're just counting. No,
Oh, I counted the dot. But
no, you never count the dot. And then what about the next one, number on the bottom?
um, 4.
Four. Okay. All right. So let's do something different here. Let's talk about how to reduce fractions. And
Hey.
it's question.
Oh, nothing. I said okay.
All right. So we're not going to reduce fractions. Now, as kind of an aside here, do you know the smallest prime number?
Um, I don't even know what a prime number is.
All right, we'll discuss that another time, but I'm going to write out some what are called prime numbers, and these are used to reduce the fraction. So let's say I give you a fraction like this, like 16 over 24. Okay. You always start by seeing if both numbers can be reduced by 2. Can the fraction be reduced by 2, the top and the bottom?
Mhm.
Are both of those numbers divisible by 2?
Yeah.
Yeah, they are. Okay, so what is 16 divided by 2?
8.
And 24 divided by 2?
Um, 12.
Okay. And then similarly, we try it again. Just like these numbers, they're divisible by 2. What is 8 divided by 2?
4.
4. And then 12 divided by 2?
7.
Try again.
Oh, wait. 8.
Try again. You're dividing 12 by 2. 12 divided by 2.
6. Oops.
6. Good job. Keep going. Divide by 2 again.
Over 3.
2 over 3. Good. Okay. So the idea here is you keep trying it until it doesn't work anymore. Okay. So I
Uh,
want you to try reducing this fraction here. I want you to reduce this fraction as much as you can.
okay. Would it be 4/12?
Keep going. If it works again, keep going. Yes, that does reduce, but keep going.
And then, um, 2/5.
Yes, perfect. Yeah. So this becomes 4 over 10 and then 2 over 5. Good. All right. Now let's look at a different fraction here. Let's look at 9 divided by 12. Okay. Does 2 go into 9? Is 9 divisible by 2?
No.
No. So the first number you always try is 2. If 2 doesn't work, guess which number you go to?
Um, 3.
3. Yeah. So is 9 divisible by 3?
Yes.
Is 12 divisible by 3?
Yes.
All right. If they're both divisible, you divide. What is 9 divided by 3?
3.
12 divided by 3?
12. 4. Sorry.
Good. Very good. All right. So here is one for you to try. It's very similar. What is 24 divided by 27? It's very, very similar to what we just did.
Would it be 9/10?
And not quite. Now two doesn't work. Two doesn't work. So you try three. Three does work. Uh, maybe just you haven't done this in a while, but division here. Are you normally allowed to use a calculator in your classroom?
Yeah.
Okay, and you're welcome to use one with me. Like I'm not anti-calculator or anything like that. 24 divided by 3 is 8. 27 divided by 3 is 9.
Oh, I just mixed up I counted or multiplied, or I just did 3. I thought it was 8. I mean, I thought it was 9, and I thought it was 10. I
Sometimes
thought
you
3.
just have, yeah. But so the point of these exercises is like you try two, if two doesn't work, then you try three, if three doesn't work, then you try five, and so on. So here's another example. Let's say it's 6/24. Okay. Does two work? It's 6 divisible by 2. It's 24 divisible
Yes.
by 2. Yeah. So let's divide here. 6 divided by 2 is,
3.
and 24 divided by 2.
12.
Okay. Now does 2 work again? Does 3 divisible by 2?
No.
No. So you go to the next number, which is 3. These are both divisible by 3. What is 3 divided by 3?
1.
And 12
Wait,
divided by
wait.
3?
4.
Good. Really good. Okay. Here's another example. Let's say it's like 20/25. Okay. You start with 2. Is 20 divisible by 2?
Yes.
But 25 is not. So that's out.
Yeah.
She's like, all right, 2 didn't work. About 3. Is 20 divisible by 3?
No.
No. So then you go to 5. Is 20 divisible by 5?
Yeah.
Divide both of these by 5. What's 20 divided by 5?
4.
And 25 divided by 5?
5.
Very good. All right. Okay, we're going to stop there for today. Go ahead and just stop the recording here.